The extremely uneven land terrain of China is characterized by a high plateau in the west and a low basin in the east. About 33% of the land is 2,000 meters above sea level. Construction in China's high-altitude mountain region usually suffers from the following inconveniences: long period of low temperature, scarcity of local raw materials, long-distance transportation of materials, difficulty in transporting and installing large-scale equipments in situ. A large number of construction plans have been scheduled for new highways in these regions, among which at least 30% of the total mileages are for medium-span bridges. The difficulty of reinforced concrete, RC girder bridge construction, lies in long period, high concrete consumption, and barely constructability at low temperature. Traditional steel girder bridge requires huge installation equipments, large amount of steel, and is difficult to transport. Neither of them is optimal choice for targeted mountainous area. How to achieve an accelerated construction of the bridge with a minimum environmental destruction in the aforementioned area is a great challenge. Wenchuan Keku Bridge locates in the mountainous transition zone between Qinghai Tibet Plateau and Sichuan Basin, known for its high-intensity seismic activity. The bridge runs along a river valley of 50 meters bottom width with staggered houses and roads. Due to the low temperature in winter, the effective construction period is only 8 months per year for this bridge, which is typical in China's mountain area. Engineers invented a medium-span, full concrete-filled steel tube CFST truss bridge. And the design goals are to achieve maximum fabrication percentage in factory, convenient on-site installation, and resource saving. Structural design. Wenchuan Keku Bridge, with a design speed of 80 kilometers per hour, has a layout of two-way 4 lanes, 24.5 meter width, 40 meter span, and 6,431 meter total length. CFST piers and CFST truss girders are used in the bridge. The CFST pier is connected to the RC pile foundation by a strengthened steel-concrete composite joint. Top-tie steel tube is used to connect standard CFST piers. Bearings are set at pier top. Piers with obstacles underneath are connected by pre-stressed steel box concrete cap beam. The girder adopts 2 longitudinal pre-stressed CFST trusses, each of which is anchored with a longitudinal rib from the steel concrete composite bridge deck. Factory fabrication. The steel structures are manufactured in factory, while the following are completed simultaneously at site: RC pile foundation, steel structure installation, concrete pouring of pier, steel cap beam, and bridge deck. On-site work is only 20%, but for RC beam bridge, 100% work is finished at site. Light structure and accelerated construction. The pier adopts CFST structure and strengthened joint and enjoys a high bearing capacity. Time is saved by avoiding the ground tie beam. Standard piers are connected directly to trusses nodes without cap beam. The empty steel tube of pier weighs only 7 tons. The steel structure of cap beam is manufactured and installed as a whole with fewer processes and weighs less than 11 tons. No formwork and steel bars are needed in the construction of pier column or steel box cap beam. Only self-compacting concrete pouring is required. The construction period on-site is shortened by 80%. In factory, the fabricated truss beam is divided into pieces suitable for transport. At site, they are reassembled into the whole span. Then the pre-stressed force is tensioned and concrete in-tube is poured. The span truss as a whole is transported and erected by particularly designed rubber-wheeled transporter and lightweight erection machine. The erection only needs 3 steps: hoisting, longitudinal moving, and laying down. The whole span truss weighs only 160 tons, and the erection takes only half a day. The bridge deck's bottom and stiffening steel plates serve not only as supporting structures, but also as formworks for concrete pouring. After trusses are erected, only the pouring of C40 steel fiber concrete is needed to form the deck to finish the girder. Experiment and research. For nearly 30 years, more than 200 sets of scaled and full-scale model static load and fatigue tests have been carried out for CFST truss structures. Experimental results show that the ultimate bearing capacity of CFST is increased by 1.5 times with pre-stress being tensioned. The capacity of steel concrete composite deck is 1.6 times to RC deck. The capacity of CFST pier is 2.2 times to RC pier. By adopting scientifically matched structural parameters of main tube and branch tube, CFST, full penetration welding, and weld surface grinding, the nominal stress amplitude of intersecting joint is smaller than stress amplitude limit and thus meets the requirements for infinite fatigue life. Resource saving and environmental harmony. Adoption of CFST piers and truss girders leads to concrete consumption 55% less than that of RC bridge, and a steel consumption 38% less than that of steel bridge. The bridge is in harmony with mountainous regions short of resources. The construction is highly industrialized, and the effective construction time at site can be fully harnessed. The construction needs no large construction site and causes minimum disruption to local residents and traffic. The bridge is in harmony with the valley terrain and low temperature nature of mountainous region. Wenchuan Keku Bridge is like a ribbon winding among mountains and canyons, and fully merges with canyons, rivers, dwellings. The bridge is in harmony with surrounding natural and cultural environment. Successful community participation. The originality of light structure design, non-formwork, and ABC technology of whole-span erection of Wenchuan Keku Bridge has encouraged intellectual exchanges which involved more than 2,000 domestic and abroad scholars. The bridge attracted more than 1 million civilians for sightseeing. Moreover, news and media coverages draw the attention of over 100 million people. Wenchuan Keku Bridge provides a competitive bridge type and a new ABC technology to meet the huge demand of medium-span bridges in mountainous area, which has been successfully applied in Hongyuan Bridge and others in Sichuan Province, with total mileage over 20 kilometers. In the next 15 years, a total length of about 9,000 kilometers medium-span bridges under complex mountain conditions will be constructed in China. Wenchuan Keku Bridge not only serves as a model for the domestic bridges, but also may provide a reference for bridge construction in the world.